Hello, the topic for this video is inscribed angles. Inscribed angles are inside of a circle. They're made by two chords, or they could be made by a chord and a tangent. The measure of the angle is half the measure of the outside arc. That's the most important thing to remember when you're working with inscribed angles. If you have two inscribed angles that are in different places, but they form the same arc, then the two angles are congruent. They are both half the measure of the outside arc. If you happen to have an inscribed angle made from a semicircle, the semicircle is 180 degrees, the inscribed angle is 90 degrees, so these will always form a right angle. This is what your graphics will start looking like. We have angle CBD, which is this angle here. It's inscribed in circle A. We're told that arc CD, which is this here, measures 140 degrees. And make sure you're writing your information that's given onto the drawing so that you can see the information you know and the information you need to find. What is the measure of angle CBD? The measure of the inscribed angle will always be half the measure of the outside arc. So just divide by 2. And the measure of the angle is 70 degrees. Here we have two questions. The first, what is the measure of arc FD? So we're looking for the distance here. Our second question refers to angle B. If angle B, which is here, equals 100 degrees, what is the measure of arc DFB? Those are two different arcs. Notice that little bit of distance between F and B. You need to see the small differences so that you know which questions to answer. For the first question, finding the measure of arc FD, we want to start at F and D and see what the inscribed angle is. If you look at the diameter, FD, we can see that this angle is made by the semicircle. These are always right angles, so it has to be 90 degrees. If that's half of the arc measurement, 90 degrees times 2 gives us 180 degrees. The second question, if angle B equals 100 degrees, then what is the measure of arc DBF? We're looking for this entire space here. If the measure of angle B is 100 and it is always half of the arc, then 100 times 2 equals 200. So you're either dividing by 2 if you know the outside arc, or multiplying by 2 if you know the inside angle. Here we have a quadrilateral inside of a circle. So we have 4 inscribed angles. We're told that arc CD measures 120 degrees, and we're asked to find the measures of these different angles. So first let's find the arc CD. That's formed by two chords which don't make an inscribed angle. So while we know that they measure 120 degrees here for the arc, we're not sure yet what to do with that information. The other given information is here. ED is 45 degrees. So if we start from E and extend out to C, then we have an inscribed angle that equals half of this entire arc. Make sure you can see that in the figure. For many students, the hardest part of geometry is converting given information into the visuals of the drawings. So if I add 120 plus 45, then I can see that arc CDE is 165 degrees. That means that angle B is half of that. So divide by 2. The measure of angle B is 82.5. Now, I can use the theorem that states that the consecutive angles are supplementary to help me find the measures of the other angles. So if I know that B here is 82.5, and that is supplementary to E and supplementary to C, then I can subtract 180 minus 82.5 equals 97.5. So angle C is 97.5 degrees, and angle D is also 97.5 degrees. Try these on your own. Spend your time with the figure, marking down the given information, and see what other information you need to find. Remember that the inscribed angle is always half the measure of the outside arc. Pause the video, come back when you're ready to check your work. Let's see how you did. I've put the answers here, and we're going to talk out the steps because they can be confusing. We're told that we have an inscribed quadrilateral and that arc BE equals 60 degrees. That's this little bit right here. That's going to be important information for the second question, where we're asked to find the measure of FBE. So the measure of angle FBE is half the measure of the arc. So if arc BE is 60 degrees, then the angle they form is 30 degrees. This is different than the angle measures in the first problem, because there the inscribed angle B is formed by these two chords. So for that question, we're going to look at angle C, which is formed here and here and takes up these 120 degrees. Angle C is half of this outside arc of 120 degrees. So angle C measures 60 degrees. Looking only at the quadrilateral, angle C and this angle B here are supplementary. So are C and D. So that's how we know that they both measure 120 degrees. Then, again, just to illustrate, when we're looking for angle FBE, we're talking about this space here on the other side of the quadrilateral. Many of your shapes, when you're dealing with inscribed angles, will have common vertex points, shared chords, and confusing imagery. Make sure you're very clear on the arcs that are formed by the two chords and exactly which angles they form. Inscribed angles can be made by two chords or by a chord and a tangent. Either way, the measure of the angle is always half the measure of the outside arc. If you have two inscribed angles that form the same arc but have different vertex points, they are congruent because they both are inscribed from the same outside arc. If your inscribed angle is made from a semicircle, then it will always be a right angle. Send your questions or comments through the Contact Us page on the website. Good luck.